Okay, example 4 says, find the area enclosed by the quadratic curve, the x-axis and the y-axis as shown below. So we've got our quadratic curve, our x-axis and our y-axis. You'll notice that there are two separate areas formed. Now, we can't get these two separate areas all in one go. Because they're separate, we have to set up two separate integrals, one for each of them. Now, if we take the first area here, you'll notice that the curve is above the area and the x-axis is below it. But we don't know the upper limit for this area. We know that the area lies between an x value of 0, but we don't know the upper limit. So we need to get this upper limit. If we take the second area, for the second area, the curve will lie below it this time, and the x-axis will lie above it this time. But again, we don't know what the limits are for the second integral. We don't know the values of x for which this other area lies between. So the problem in this question straight away is we need to get the x-coordinate of this point and we need to get the x-coordinate of this point. These will be the limits for the integrals. So we start off by, we need the limits for the integrals that we're going to set up. And those are found by where the curve cuts the x-axis. So where the curve cuts the x-axis. Okay, so let's get where the curve cuts the x-axis. So curve cuts x-axis when we set y equal to 0. So we go to our curve and replace y with 0. So we're going to get 0 equals x squared minus 3x plus 2. Okay, we've got a quadratic equation here, so product and sum. So our product is going to be positive 2 and our sum is negative 3. So our two numbers then will have to be minus 2 and minus 1. And then we're going to break up our middle x term as before. And then factorise in pairs as we usually do. And we factorise one more time. So product of two brackets equals 0. So first bracket equals 0, which means x would equal 2. Or the second bracket could equal 0, which means x would equal 1. So we've got our two values of x, so these are the limits that we're going to need. So what we can do straight away is if we go back to our diagram here in example 4, we can put these two values of x. So the smaller one is going to be 1. And the larger limit is going to be 2. So we're also going to label each of these areas. I'm going to call this area here A1. And we're going to call the other area A2. Okay, so let's start with A1 then. So area 1. So for area 1, so the formula a equals the integral, and then we have a and b are the limits, and it's top minus bottom dx. Now, copy down our integral sign. So let's go back to the diagram. So we look at A1. The limits, remember, are the values of x, the values on the x-axis that the area lies between. So this area here lies between 0 and 1. So those are our limits. So we put the smaller limit at the bottom, bigger limit on the top, and then open brackets. Now top, so go back. The top is what is above the area. So clearly the curve is on the top here. So we put all the non-y values into our expression. So we replace where it says top with x squared minus 3x plus 2. So we've got x squared minus 3x plus 2. And then we're subtracting the bottom now. The bottom is what's underneath the x-axis, so, or sorry, what's underneath the area. What's underneath the area here is the x-axis, and the equation of the x-axis, remember, is y equals 0. So we're just subbing in 0 into the bottom. Okay, so get rid of the brackets then. So we're just integrating x squared minus 3x plus 2. Okay, we're ready now to integrate. So we're going to put square brackets in this time because we're integrating with limits. So add 1 to the power, divide by the new power. So we're going to have x cubed over 3. Add 1 to the power, divide by the new power. We're going to have minus 3x squared over 2. Integrate a constant. We just put an x on the end of it. Don't forget to add on a constant, plus c. And then our limits go immediately outside after it. Break up the square bracket into 2 separate square brackets. And then remember to put a minus between them. So we're going to chuck the bigger limit into the integrated expression in the first square bracket here. So replace x with 1. So we're going to get 1 cubed over 3 minus 3 times 1 squared over 2 plus 2 times 1 plus c. And then we're going to chuck the smaller limit into the integrated expression into the other square bracket. So we're just going to get 0 cubed over 3 minus 3 times 0 all squared over 2 plus 2 times 0 plus c. Okay, let's tidy up each bracket then. So the first bracket, we're going to be left with 1/3 minus 3 over 2 plus 2 plus c. And then our second bracket, we're just going to be left with nothing minus nothing plus nothing, which is just nothing, plus c. So go to our calculator, tidy up first bracket. So we've got 1/3 minus 3 over 2, and then we're adding on 2. So that's going to give us 5/6. So we've got 5/6 plus c, and then we're subtracting nothing plus c. So again, the c's always cancel out, so we're just left with 5/6 minus nothing, which is just going to give us 5/6 units squared. So we've worked out the area of A1. If we go back now, we've got to get the area for A2. So A2, so area A2, the area is equal to the integral of A and B, top minus bottom. So let's look at A2 then. Okay, so A and B are the limits, so we're looking for the values of x that the area A2 lies between. So it lies between 1 and 2, so the upper limit, bigger limit goes in the top, 2, smaller limit goes in the bottom, 1. and then open brackets, top then. So top is the curve that lies above the area. So what lies above the area is the x-axis, and the equation of the x-axis is y equals 0. So we replace the top with just 0, all the non-y terms in that equation. Close brackets, and then we're subtracting, open brackets. The bottom then is the curve that lies underneath the area. So it's the actual curve in the question. So x squared minus 3x plus 2, we sub that in. Remember, don't sub any y terms, it's all the non-y terms. So the bottom is x squared minus 3x plus 2. Okay, and then we're going to get rid of the brackets. So multiply bracket by negative, we're going to get negative x squared plus 3x minus 2. Now that the brackets are gone and there's no x's on the bottom and there's no roots, we're ready now to integrate. And because we're integrating with limits, we're going to put square brackets in. Now we integrate each term. So add 1 to the power, divide by the new power. So we're going to get minus x cubed over 3. Add 1 to the power, divide by the new power. We're going to get plus 3x squared all over 2. Integrate a constant or a number term. We just put x in the end of it. And then don't forget to add a constant. Close our brackets and then put the limits outside. Same again, we're going to break up the square bracket into 2 separate square brackets with a minus between them. We're now going to sub the top limit into the integrated expression in the first square bracket. So we've got minus and then replace x with 2. So 2 all cubed over 3 plus 3 times 2 squared over 2. Minus 2 times 2 plus c. We're now going to sub the bottom limit or the smaller limit into the integrated expression in the second square bracket. So we've now got minus, we've got 1 cubed over 3 plus 3 times 1 squared over 2 minus 2 times 1 plus c. Okay, let's tidy up then each square bracket. So 2 cubed is 8, multiplied by the minus then, that's minus 8 over 3. 2 squared is 4, 4 threes are 12, divided by 2 is 6, that's plus 6, minus 4, plus c. And then tidy up our other square bracket. 1 cubed is 1, multiplied by a minus is minus 1, and that's over 3. And then plus 3 over 2, minus 2, plus c. Okay, let's tidy up each square bracket into a single number term. So we'll use our calculator then. Minus 8 over 3, plus 6 minus 4. That's going to give us minus 2/3. So we've got minus 2/3 plus c. Then copy down our minus and then tidy up the second square bracket. So we've got minus 1/3 plus 3 over 2, and then we're subtracting 2. So that's going to give us minus 5/6 plus c. And again, remember the c's cancel because you're going to plus c minus plus c, so they're gone. So we're left with minus 2/3 minus minus 5/6. So that's going to be minus 2/3 plus 5/6. So again, go to calculator, minus 2/3 plus 5/6. And that's going to give us 1/6 units squared. So we've now worked out the area A2. So overall, A1 plus A2, the total combined area. So if we flick back, A1 was 5/6. So we've got 5/6, and then we're adding on A2, which is 1/6, and that's going to give us a total of 1 square unit. That's our final answer. So what we found is the overall shaded area. So you cannot get, as I say, you cannot get these two separate areas in one go. What you couldn't do, you couldn't integrate between 0 and 2, because if you did, you wouldn't get the right answer. And the reason for that is because you notice the curve is above the area for this area, but yet the curve is below the area for the other one. So there's no consistency there. Okay, so just be careful with that. When the areas are separate, you must set up separate integrals for each.